Hello fam, this is Dr. Shozi and we are still on tutorial class 2, learning opportunity 2. Now we are looking at problem number 2. The problem wants us to show that the function f at z equal to e to exponent the conjugate of z, which is z bar, is nowhere differentiable. So we are required to show that the function f at z equal to e to exponent z bar is nowhere differentiable. So our first goal there is to write function in the form u plus iv. We want to write it in the form u plus iv. So what do we know about this function? So let us start. So let's start with our solution here. So for our solution, we start by realizing that if we have f at z equal to e to exponent z bar, that is the same as e. Instead of z bar, we have x minus iy because that's what z bar is in terms of x and y. That's what z bar is. And we can write this as e to exponent x times e to exponent minus iy. So this is the same as e to exponent x into, then e to exponent minus iy is the same as cos y minus I sin y. That's the same as cos y minus I sin y. So now, if you remove by e to exponent x there, that bracket, you can see now that will already be written in the form u plus iv. So now that's why I'm going to say let u as a function of x and y, of course, to be equal to e to exponent x cos y. And let v as a function of x and y to be equal to e to exponent x sin y. That's actually negative e to exponent x sin y. So that is v. It's negative e to exponent x sin y. So from here, then we see that now our f at z is in the form u at xy plus I v at xy. And from this, we can find our partial derivatives. From this, we can find the partial derivative of u with respect to x. So what do we get out of that? The partial derivative of u with respect to x, we are getting e to exponent x cos y. And the partial derivative of v with respect to x, that would be minus e to exponent x sin y. And now the partial derivative of u with respect to y, that would be minus e to exponent x sin y. And the partial derivative of v now with respect to y, that would be minus e to exponent x cos y. So that's what we have. So by the Cauchy-Riemann equations, we have that the partial derivative of u with respect to x should be equal to the partial derivative of v with respect to y. And the partial derivative of u with respect to y should be equal to a negative of the partial derivative of v with respect to x. And this implies that we should have e to exponent x cos y being equal to negative e to exponent x cos y. And negative e to exponent x sine y being equal to e to exponent x sine y. So this is what we should have by Cauchy-Riemann. And this means that 2 e to exponent x cos y equal to 0 and 2 e to exponent x sine y equal to 0. And since we know that e to exponent x is different from 0 for all x in C, 2 to exponent x, 2e to exponent x is also different from 0 for all complex numbers x. No matter what x is, we know that 2e to exponent x is different from 0. Thus, we have the only possibility that we can get a 0 is when cos y is equal to 0, and the only possibility that we can get a 0 this side is when sine y is equal to 0. So this is what we have. So when cos y is equal to 0, this implies that y is actually equal to pi by 2 plus k times 2 pi, where k is an integer, and y this side is the same as 0 plus k times 2 pi, where k is an integer. So this is what we have. This is what we have. Now we are going to analyze this. We're going to analyze this. So if you can see here, if you can check carefully, you can see that we have two sets which are distinct. We have two sets of values of y which are distinct. Since two distinct sets of values of y are obtained, the Cauchy-Riemann equations cannot be satisfied anyway. We don't seem to be able to satisfy these Cauchy-Riemann equations for this function to be differentiable at some point. So they don't seem to be satisfied anyway. Thus, for this reason, f at z is nowhere differentiable. That's a full reasoning as to why we can conclude that f at z is nowhere differentiable. We see that by getting these values here, they don't intersect anyway. They don't seem to intersect anyway here. So for this reason, we know that at no point we are able to satisfy the Cauchy-Riemann equations, and hence this function is nowhere differentiable. So this is how we end this video. We're going to meet again on the next video. I hope this made sense. Thank you.